a couple of things here before we get started. Turn that on. So the all of your homeworks have now been, whatever I could see, I scored and entered. If you think there's a discrepancy between like what you did and what I saw, what should we do in that case? Resync and then send me an email and be like, hey, I don't think everything synced through. Can you go back and recheck this? Again, there's no penalties for late stuff for the first month or so, but we're cruising in close to the end of the first month here. So we need to make sure that we're getting comfortable getting those homeworks in and synced in and all that kind of stuff. Okay, because Mr. Kulik will stop being so generous about the late stuff here pretty soon. That hasn't happened yet. So again, this being the second homework check still, if you had some issues where it didn't seem like I could see everything you needed or you're just late on something, send me a resync or finish up and send me an email when you're all through and I can go back and look at some stuff. Probably won't happen today, might not happen tomorrow, but I'll get to it. Okay? Typically I send you back a thumbs up after I look at whatever you told me to look at. With the homeworks, one thing I want to say here again, still some of us are writing our answers next to the questions. Please don't do that. Even if you put the questions on the same page as your homework, that's fine. Just like make a column, number them, like a column next to the page, just so it's really clear. A lot of the problems are just like, there's not enough space to put any kind of work next to it, and it just gets really messy and difficult for Mr. Kulik to kind of look at what's going on there. So if you have been writing your answers next to the questions, please stop doing that. Okay, just make a separate column of things. If you're writing it on in OneNote, that's fine. But just like give me a little bit of space so it's a little easier for me to see what you did. Everybody cool? Not a lot of us are still doing that, but I'm still catching a couple of people. And then a couple of observations from the homework quizzes. I got those all graded and entered today, so that was done. So a couple of observations that I noticed that I should talk about because it applied to many of us. So let's say I have an equation like this, and we square root both sides of it. What do we get? Plus or minus 2. A lot of us missed the plus or minus on this. Again, anytime you square root both sides of an equation, we generate a plus or minus. So please make sure you're remembering that. Now that's a forgetfulness thing, probably, for most of us. So here, let's say I have x squared equals y squared plus 9. If I square root both sides of the equation, is that the same as doing this? Yeah. No, it's not. That's okay. I'm just making a point. It's not really, I'm mad at you. What is a radical really the same as? It's the same as an exponent, right? Remember that like square root of x is equal x to the 1/2. Can exponents distribute? No! This is very bad. The way you'd write this is just plus or minus the square root of y squared plus 9. Nothing else you could do to that. You could not simplify that any further. Lots and lots and lots of us got real creative with our application of square roots. Just trying to like clear that up so we can clean it up for futures. Remember, multiplication, division, very special. These are the only two operations that you know that distribute. If you try to distribute anything else, that's a mistake. Everybody's clear? Okay. I just want to make, again, no big deal. It's the beginning of the year. That's the point of doing these things, is to give me some feedback about what we need to go over and what we don't need to go over. This is like an Algebra 2 skill. It's been a minute. No big deal. But just want to reemphasize, if you're distributing something other than multiplication and division, think twice. Is everybody okay? And in general, if you're thinking to yourself, oh, is that okay to do? Well, just try something like that's the square root of should be the square root of 13. If I distribute that, I get 5. Is 5 the same thing as the square root of 13? No way, Jose, right? If you're ever in doubt, just plug some numbers in and be like, can I distribute a square root like that? And just try some easy numbers, and you should come up with the answer being, no, I cannot do that. Ideally, if you're picking numbers, stay away from ones and zeros. Sometimes you can get the behavior that shouldn't work if you're picking kind of trivial cases with ones and zeros and stuff. But anyways, everybody cool? Okay. All right. Today we're going to pick up where we left off in section 1.7. I just want to look back at our notes from last time and double check where exactly that was at. Okay, got it. Yes, Rita. Oh, sure. You want to do that first? Yeah. Go ahead.
So I just have a question about 1 to 1. So I know if 1x value is
Which number did you say?
Oh, I was thinking in general about 1 to 1.
Oh yeah. Okay.
I know if 1x value goes to multiple y values, but it's not a function.
Right.
Could it still be 1 to 1?
Yes.
So as long as it's going to distinct y values, if it's 1 to 1.
Yes.
Okay.
So let's do this. So this is something, not a function, but each of the y values is used just one time.
So it's supposed to be y value.
So it could be 1 to 1 still.
Okay.
Yeah, we're just looking at the y's for the 1 to 1 piece.
And then could you also do number 40?
Yeah.
Thanks.
No problem. You don't have to apologize. I should have started with this, so 40's got to be over here, right? No, it's over here. Actually, I don't know. Let's zoom in before. Nope, it was on the third page. All right. Ooh, boy. Says, for each of the following, determine if the relation is a function. Well, obviously that's 40. Yes, it's a function, right? Pass the vertical line test. No problem there. State the domain and range. All real numbers for each, right?
Okay.
Assuming that there's arrows at both ends of the graph, which I think is the normal assumption for something like that, since it shows the line going off the page. You good with Y?
Oh, yeah. I was really range.
Okay. Is it 1 to 1? No, right? Because it fails a horizontal line test.
Right. Oh, yeah.
And then is the function, or is the inverse going to be a function? Well, no, because the original function wasn't 1 to 1. And then to find the inverse, what I would just do is I would pull the points from the graph and just kind of try to plot something out here. So this looks like maybe 5, 10 here. And that looks like maybe -6, 0. And that one looks like maybe -2, 0. And down here looks like 0, -6. And that looks like maybe 1, 0. And then I would just plot the points and kind of connect everything after I transpose them. So I'd have -6, 0 would be here. And then 0, -6 would be down there. That's convenient. I'd have 10, 5. So that's going to be like there. And then I'd have 0, -2, which would be like there. Then I'd have 2, 1, which would be like here. So this would be yeah, I drew all those. Okay. So this guy is going to be like going this way. And then -6, 0 goes to like here. Oh my goodness, that's why that's in such a funny spot. What did I do wrong? That's -5, 10, Mr. Kulik. So that should be -5, 10. Oh, I'm sorry, 10, -5. So that's there, and then this goes to there. And then and then we go down to this one, and then like that, I think, right? Something like that. Does that feel okay? Maybe I should have picked a different color than blue. That's pretty ugly looking now, but so I'm too pot committed to change it. Sophia?
My second question. So, before 2, there's no lines, so I would think it's a function, but none of the x's would be itself, so.
Then it's a function.
So it is a function.
Oh, yeah.
Oh, so it's like just points that you can.
Sure. Yeah, pass the vertical line test, right?
Okay. Oh, and then for like let's say like 31, when it's asking for the
Oops, hold on a second while I grab the problem so I can look at it at the same time. Okay, 31, got it. Oops.
I kind of like put the
So 31, which part am I looking at?
the
B, okay.
yeah. So when I'm doing that, I kind of put like a squiggly and then all the x's.
Yeah, absolutely, that's how you list it. 100%.
I thought it'd be like a little like bracket or something. So.
Nope, you would just do like squiggly, then 1, 2, 3, 4, 5. That's the domain, and the range would be squiggly 2, 3, 4, 5, 6.
And I feel like the x and then the half.
Yeah, sure.
Okay.
Yeah, that's. I mean, you don't need it, but it's okay. Oh yeah. Oh, I'm sorry. Like here, you're saying.
Yeah.
Yes. Okay. Yeah. 100%. That's great. Love it. Looks wonderful. Elena, did you have a question too?
Yeah, so when you were explaining 42, I think you said, it was talking about the 1-to-1 for 40, and that it wasn't 1-to-1?
Correct.
Because it didn't pass the vertical line.
Horizontal line. The function f doesn't pass a horizontal line test.
Okay.
That means that f inverse wouldn't pass a vertical line test, which is why f inverse isn't a function. But I should be able to tell that just by looking at f. So the horizontal line test is telling us that f is not 1-to-1, which in turn means f inverse would not be a function. Does that?
Yep.
Okay. Again, you have to be careful about like what our verbiages are there, right? Giselle.
Could you do number 30?
Yeah, dude. Okay, so remember that f composed g is just like g of f of x. So the way I like to look at this is I look for an inside part, that's going to be my g of x, and I look for an outside part, that's like my f of x. Okay? So in this case, the inside part to me looks like the x minus 3. And then the outside part looks like the cube root. So there's my f and g. That's all I'm doing. That's all I'm really looking at.
Okay, thank you.
Now, is there like more than one answer to this? Yeah, man. You could have lots of answers for some of these. Now, is it like I can make infinitely many answers to this? This would be the obvious one I'd expecting. But there's like a super special cheat code anytime you get a question like this. What's a super special cheat code? Well, I just pick one or the other to be the identity function. And the other can just be h of x. Right? Like that's the, well, no dir. If I plug h of x in for x, I get h of x. It's like, oh, well, you could do that. That's not what I was hoping you would do. But like, it's worth pointing out that like any problem of this type could be done that way. As like a, oh, you're smart, but you're too smart for your own good kind of question answer. You know what I mean? Okay. Did I get everybody? Was anybody else waiting to ask about anything else? Sorry about that. If I ever start with forget about question time, you're obligated to stop me and remind me that like, hey, I had a question from the homework. I'll be like, oh yeah, we didn't do that. Sometimes I just get excited about the math and want to get started. You know, I'm sure it happens to you guys all the time.
Yeah.
Yes.
Remember the fourth grade? How do you find that information?
Yeah, we're going to talk about that today.
Oh, okay.
We hadn't talked about that yet.
Okay.
So you couldn't have started those, which is okay. Very good. I'm glad you got that far and at least thought about it. Okay. I mean, you might have remembered it from Algebra 2. But if you didn't, that's okay. We hadn't gone over it yet, which we're going to do right now. Everybody good? Fantastic. What a great lead-in. It's almost like you knew what I wanted to start with there, Ava. All right. So last time, we spent a lot of time talking about inverses. And we talked about how to, if I gave you a mapping diagram, you guys should be able to write the inverse for that. If we gave you a set of ordered pairs, you should be able to write the inverse function for that, or the inverse of that, not even necessarily a function. Or if we gave you a graph, you should be able to write the inverse for that. And then Ava says, what if we have an equation like in number 43? How do I do that? That's what we're going to talk about today, and we're going to roll through a bunch of examples. Here's the essential steps. So what we're going to do is we're going to replace the f of x with a y, and then we're going to solve for x. We'll swap the x and y's in our equation, and then replace y with f inverse, and we're donezos. So I have a whole alphabet soup of examples here. All right. So let's say we have the function f of x equals 3x minus 7. So start by replacing that f of x with a y equals. Now we want to solve for x, so I want to get the x by itself. First thing I should do is add 7 and then, okay, can I do that all in one step? You guys are probably game for that, right? Everybody's cool with what I did there? You don't have to do it in one step if you don't want to. If you want to write in 2 steps, no biggie. And then we swap our x's and y's. And then we'll rewrite that as f inverse. And that should be my inverse function. Not too bad. Mr. Kulik, how do I know if that's right? Oh, you want to check that, do you? That's a good idea. How do we check if 2 functions are inverses? No, we can do it algebraically, which is even better than like looking at a picture, because like sometimes it's not super obvious. Is that a reflection across y equals x or not? I can't really tell, especially if it's like a really confusing looking function. So remember, well, that's not what you said wasn't wrong. I want to be clear though. But this is a little bit more precise. Remember, we said our definition of inverses were f and g were inverses if f compose g was equal to g compose f, which was all equal to x. So that's what we're going to do. So we'll do f of f inverse of x first. So f was 3 times x minus 7, but in this case our x is x plus 7 over 3. Right? So the composition's done. What do you notice I can do to simplify here? Come on, guys. Times 3 and divides by 3. And then what can I simplify here?
7.
Yeah, plus 7 minus 7. And just equal to x. Great. I'm not done, though, because I also have to check the other direction. So f inverse says I have x plus 7 over 3, but in place of x, I have to sub in 3x minus 7. And then what do we notice can simplify here right away? Yeah, the 7s can cancel out, right? There's no reason that parenthesis needs to be there since there's no multiplication or division involved. And after that, then the 3s can cancel out. And what are we left with? Just x. Oh, definitely inverses. Good thing we did that right. But now we know. Everybody cool? Okay. Is the checking required? Not unless we ask for it, right? Will there be problems where it's like, show these 2 things are inverses algebraically? Yeah, for sure. Is this a good example of doing that? Yeah. But do I have to do it to find an inverse? No, not if you don't want to. You could. You like all these hypothetical questions? Or just answering it for you? It's kind of fun. No? Yeah, you're fine. Be that way. I don't care. You know? It's just being mean is all you're doing. Let's give this guy a different name. We just did F. Let's do G now. G! Now this one's a little trickier. So I have 2x plus 5 over 5x minus 8. That's my g of x. So what do we start by doing? Well, we replace the f of x with a y. That looks too much like a 3. Bad 5ing, Mr. Kulik. Hey, you leave my 5s alone. All right. How do I get the, what do I need to do first here to solve for x? What's different from this problem than the previous one? I have x's in 2 places. Yeah. Uh-oh. What should I do? Multiply by? Yeah, that's a good idea. Right? Get rid of the fraction. That usually is quite helpful. So we do that. Everybody happy with what I did there? Notice I distributed the y and show that. Are we okay with me doing stuff like that? It's just light simplification there. Right? You're all right with that. What should I do next? Subtract 5 from each side? Well, in general, what are you trying to do here by doing that? What's that? Somebody whispered something. Just speak up. It's okay. If you're wrong, it's not a big deal. I'll tell you and say like, oh, okay. Like, maybe not. And then tell you why. But if you're right, I'll be like, oh yeah, it's a great idea. There's no penalties. What do you think? Giselle, did you want to answer? Like, what are you trying to do by subtracting 5 from both sides?
I don't really know. I was thinking like subtract 5 from each side and divide each side by 2, but then I realized there's another x on the
Yeah.
side, so I don't know.
So doing that's probably not the route you want to go. It's not Bella. Gigi.
Yeah. You factor for y.
What?
You factor for y.
Well, that would just like, that's not going to really help me because it's just the same as the step before,
Yeah.
right?
I know. Okay.
But you could do that. It's not going to be helpful for us. Rita, did you have an idea? You had a hand up at one point.
Okay, I'm trying to like really bad, but can you like divide by 5x?
Oh, don't do that. You're just going to make fractions. Here's what we're going to do. We're going to put all the things with x's on one side by subtracting 2x over, and all the things without x's on the other side by adding the 8y over. Notice no division has happened here, right? All I did was just a little adding and subtracting of things. Yeah, who said it? Good job, Elena. So the next step is to now factor out the x, right? That's the way we go from variables in many locations to variables in one location, is by factoring. And it's the easiest kind of algebra 1 factoring you ever saw. It's that greatest common factor factoring. Is this now looking good for you guys? We can then just divide by the 5y minus 2. And then plug our y's in for x's and our x's in for y's. And that'll be all she wrote. Oops, except we called this guy G, not F. What do you guys think? right? It's like, okay, that was a little sneaky, but I could do that again now that I've seen the trick, right? The hardest part is remembering that factoring step at the end to like, that's how we get many x's to 1x. We're going to check this though, because, well, it's a good algebra review. Everybody okay with that plan? Yeah, most of this is designed to just be good algebra reviews, right? So I do g, so that's going to be 2 and then x plus 5 over 5 times x minus 8. And the x in this case is this fraction. Oh no, look at this weird looking thing. Does anybody remember what this is called when you have fractions inside of fractions like this? We had an Algebra 2 name for stuff like this. It's called a complex fraction. Do you remember talking about those? That term sound familiar? Yeah, okay. How do I go about simplifying something like this? Because boy, it's a doozy looking here.
Oh. I remember that. Yeah, you have to be like a team of find the common.
Oh, yeah.
Yeah, let's.
It's in there somewhere.
Yeah, that sounds all we need. Well, there's lots of ways to do this. You could like, oh, I'm just going to treat it as like a division problem and find a common denominator in the numerator and denominator, like add the fractions and then do the division. Yuckarooski, you could do that though. What I would do instead is I would look at all the fractions at all the levels and look for the least common multiple of the denominators. If I look, the only denominators are 1 and 5x minus 2. Everybody agree with that? So the least common multiple is just 5x minus 2. So I'll multiply to the top and bottom. So that's going to distribute. When I multiply to the first term, the 5x minus 2's cancel. And when I multiply to the second term, well, the 5x minus 2 is just going to multiply to the constant. Does that all look okay to everybody? What we did there? And boy, that looks a heck of a lot nicer than what we had just a moment ago, right? Now we just do some distributing. 16x plus 10 plus 25x minus 10 over 40x plus 25 minus 40x plus 16. It's going to give me 41x over 41, which is just equal to x. Then you would do the other side. I'm just going to skip this though. It's really the same process. You could work through it, but we know what it's going to come out to because Mr. Kulik made sure we did the problem right. So we know it's going to work. It's going to be kind of the same algebra as before. The numbers will be a little bit different in places or whatever, but like the exact same idea. Elena?
So if you do both, like one equals x but one doesn't, it's not?
It would be not an inverse. And that could happen if you did everything correctly, if your inverse wasn't a function. So like if you had a plus or minus or something in your inverse, you could do both compositions and one would give you x, the other might give you like plus or minus x or something. And that could happen. But all right. Let's do another one. E, F, G, H is my next letter in the alphabet. Okay, so again, we're looking for inverses. So get the x by itself. What's the first thing I should do? Add 4, and then divide by 3. And we'll square root both sides afterwards. What do I have to remember? Nope. Plus or minus. Of course. We'll go ahead and swap the x's and y's. Notice here that I'm not even caring about the radical in the denominator, even though there's one there. I'm not going to worry about it. Again, we talked a little bit earlier how this is just like more of a matter of style or preference than anything else. But, what do we notice about our inverse? Not a function. Great. Why not? You have that plus or minus tacked on there, right? Almost any x value you pick in the domain other than -4 is going to give you 2 y values, right? Why not -4? Because it's plus or minus 0, and 0 is just 0. There's not plus 0, minus 0, just 0. Everybody's cool with that? Now, what if I wanted to... what if I wanted this thing to be a function? What if I'm like, okay, Mr. Kulik, I'm not jiving with this whole my inverse isn't a function thing. Is there something I can do to turn this in, to turn this problem into something that can have an inverse? Sure. The idea here is going to be, what I need to do is restrict the domain of f. So if I think about f, what does the graph of f look like? It looks like this, right? It's a parabola that opens up whose vertex is at 0, -4. Everybody's okay with me looking at the equation and can tell that? How can I tell it opens up? The leading coefficient is positive. Excellent. How can I tell the vertex is at 0, -4? -4 is the y-intercept, and since there's no x term, the x-coordinate in the vertex has to be at 0. So it's just 0. So the vertex is at the y-intercept. So does everybody kind of remember that from last year? Just maybe reminded of that. It's like, okay, that sounds like something I knew at one point. I'll settle for that. What else could you have done? Type it into your calculator, right? You can still do that. Okay. So, what's the issue with this guy? How do I know that the inverse of this will not give me a function? It's not 1-to-1, right? My function isn't 1-to-1. So what I'm going to do is I'm going to make it 1-to-1 by restricting the domain so that I do not have any more repeated x or y coordinates. So I would either take this half of the graph, or I'd want to take this half of the graph, right? either one of those would give me something that is 1-to-1. Does everybody agree with that? Which one do you suppose I'm going to choose? The right side, because the values are positive. No reason in lugging around an extra negative sign if I don't need to. If I got my choice, I'm going to do that. So if I do that, everything stays the same until I get to here. So I'm just going to put an arrow there, just showing that I'm doing the same work as I did before. Now, what can I say about the plus or minus? Since x has to be positive, or I should say non-negative, that plus or minus can just go away. Does everybody see that? Because I know that x has to be 0 or bigger. That plus or minus, x is equal to plus or minus something. Oh, no, it's not. X has to be greater than or equal to 0. I just drop the plus or minus. And then I can take this all the rest of the way home. Is everybody okay with what we did there and why I did it, why it worked? This is an important concept because when we talk about inverse trig functions in another, it'll be a couple of months probably, this idea is of restricting the domain becomes really important and something we have to account for when we start using the inverse trig functions. Okay. I am going to skip the old showing that these guys are inverses. Is that okay with you guys? Where's the place that where would we, just hypothetically, where would we get into trouble if I use the red answer? That'll end up giving me plus or minus x instead of x. Right? Not a big deal, but like worth pointing out. What letter are we on? Is it C? D, thank you. H, I think we're on letter I. Oh, I hate that. That's okay. Why does Mr. Kulik say, oh, I hate that? I is usually reserved for the imaginary number. It looks kind of weird to be using it as a function name, but like, I'm going to get over it because this is the bet I've made, so I might as well lay in it. Should just call these all f of x's, but Mr. Kulik decided to get cute here. And now he's being punished for it. Best laid plans of, mice and men and all that. Well, mice anyways. All right, so same idea here. Replace the I of x with a y. Trying to get x by itself. What do I need to do first?
Square root.
Square root?
Square.
Square both sides, right? To cancel the square root. Maybe you meant cancel the square root when you said square root. That's what I'm going to choose. And then we'll subtract the 5 and divide by the 12. And then we'll swap our x's and y's. And there's our inverse. Who thinks this is 100% correct? Probably nobody after I ask this question, right? I've probably done this enough times that you guys are starting to go, when he asks me if I think this is right, I should always answer no, because there's usually something wrong with it. What is the thing that might be wrong here? It's a very subtle, very theoretical kind of thing. So this is what I of x would look like, right? But this is what I inverse of x is looking like. What's wrong? That part should be part of my function inverse, right? If I'm really reflecting this across the line y equals x, is that okay? Now, would I mark you down for not doing that? No, but if we're going to write stuff down and we're going to say stuff as inverses, we're going to like mean what we say. You know what I mean? Like I'm going to do it the right way for you and talk about like, okay, this would be fine if you wrote this as your answer, but it's not all the way correct. This is what's wrong with it. Is how you'd fix it to make it all the way correct. Would I hold you to that same standard on a test or quiz? No, that's pretty sneaky to have caught, right? How many of us even were thinking along those lines of like that was going to be the thing that was wrong? It's like, oh, yeah, the graphs don't match up the right way. Yeah, but that's that's the issue. Is that okay? Did you guys see what? You see the issue though? Once I point it out to you, it's like, oh yeah, it doesn't look right. Coming up with that on your own though is like a whole different story. H-I-J is the next letter. The alphabet, guys. All right, here comes Algebra 2 review time back hard. What type of function is this that I've just written? What's the name for that? Where's the variable at? Where's the variable at? The exponent. So this is a exponential function? Yeah. Okay. So to solve an exponential function, first thing I'd want to do is, nope. I want to get the exponential part by itself first. So what do I have to do before I can log both sides? Get rid of that coefficient of minus a half. So I'd multiply both sides by -2. Is everybody okay with that? Right? We're just multiplying both sides by -2. Gigi.
Why are you like multiplying it?
Well, how else do you, I mean, you want to divide by negative a half? That's the same thing.
No, but why are you getting rid of the negative half?
Because I'm trying to get the exponential part by itself. That's the exponential part. The variable is only attached to the 3, not to the 1/2. So I can just move that 1/2 out of there. And yes, could you take the log of both sides in the first place? Sure, you got quite a bit of mess to clean up afterwards if you go down that route. Doing this first makes life much easier. In general, you guys, so you go this way when you're simplifying, and you go the opposite direction when you're solving, right? Everybody kind of agree with that? So I should be doing the multiplication division. I should be undoing that before I get to that exponent that I'm trying to undo later. Does that ring a bell? How many of you guys are just now realizing, like, oh my God, it is the reverse PEMDAS to do solving? That's okay. Sometimes that's not emphasized always. But it's like one of those things that, like, when you see it, it's like, oh, boy, how did I not know that already? Would have been helpful. All right. Thomas, now we want to do the log of both sides. Which log? There's no wrong answer here, but there's an easy answer here. Log base
10.
3. I love it. Why 3?
So you can cross out 3.
Yeah, if I want the log base to match the exponent base.
First time.
Nope.
Let me be clear, none of the other answers people gave were wrong answers. They're just not as convenient. No. In fact, they're still right answers. They're just not as convenient of answers. And you'll see why in a moment. Because what Sophia said is that log base 3 can cancel directly with exponent base 3. And we don't have to do any messing around with, like, change of base formulas or like any of the log properties or anything else to get that x out of there. Just whatever was in the exponent just comes tumbling right out. Nothing attached to it, which is preferable, right? We still doing okay? Next step would be divide both sides by 4. I'm going to write it as times 1/4 though, just so it's really clear as to, like, that is attached outside the logarithm rather than inside the logarithm. It wouldn't be wrong to do like this, but I want to just be really clear as to, like, where that divide by 4 is coming in at. Is that okay with you guys? And then we swap the x's and y's. And then we have, what letter is this? J, I think. So there's my inverse. Does anybody think there's a problem that I have that negative sign inside my logarithm? Can I take the log of a negative number? No, I cannot, but is that a problem? No, because the x is a variable, right? Can x be negative? And negative times negative is positive, and then there's no big deal that we're logging stuff. So it's okay that there's a negative sign inside the logarithm. Everybody's cool? I think I saw that come up on the on somebody's homework quiz where they're like, oh, there's a negative under the square root. I'm like, yeah, but there's a variable attached to it, so it doesn't matter. But, you know, that's something that's not here nor there. Okay, let's do the check here, because algebraically this is worth reviewing. Yes? Because most of us probably don't super remember our logs from Algebra 2, right? That was a while ago, and well, like logs are kind of weird, right? Yes.
We have to like show how we check it in our homework.
Uh,
It's just like.
only there. Okay, so there will be homework problems where I give you two things and want you to show that they're inverses.
Okay.
But I don't think I ask you to check in the homework.
Okay.
But because I ask you to like, here's two things, show they're inverse, I might as well just do them while we're doing this because it's just like, I already have the two things that are inverses. You know, like I don't need to make it a separate, you know what I mean?
Yeah.
So like, no, you don't have to do this every time you find an inverse. But I will ask you to do this individually on a problem. And it just kills two birds with one stone kind of thing. All right. Everybody's cool with how I did the composition there? All right, let's start simplifying. What simplifies first? The 4 and the 1/4, right? Yep, that's correct. What cancels or what simplifies next?
Oh, the log 3.
The log base 3 and the exponent base 3 cancel each other out. And what tumbles out of that? Negative 2x. Sophia?
The half, negative half.
That was in the original problem. That was part of j of x.
Oh.
Right.
Oh.
That was an easy one for me. Right? Like, okay, sure. Of course. And I'm going to do both directions this time because, well, it's again good review. So far, so good. Let's go ahead and do that composition. Everybody good with how we did that composing? Put your phones away. Thank you. What cancels for, or what can we cancel first? Excellent. The negative 2 and the negative 1/2. Great. And then the log 3 and the exponent base 3. And then obviously the 1/4 and the 4. What do you think? So far, so good? All right, I have one more example from this section, the section that never wanted to end here. But this is good algebra reviews, right? How many of you have thought about a log in the last, 9 months? Probably none of us, right? Maybe if you took the ACT over the summer, you reviewed some logs for that. What letter am I on now? F. And I think we're on K of X now, right? Yes. such a boss. All right. K of x equals 5/3 natural log of 7x minus 1. What do I want to do first? Nope, not divide the 7. It's inside the log. Multiply by 3/5. Yeah, we want to get the log part by itself. So far, so good. Now, what do we have to get rid of next? The natural log. What is going to cancel out a natural log? Exponent base e. Why e? The natural log is log base e. So we want the exponent base that matches the log base. Do you have to do that? No, but it makes it massively more convenient if you do. Again, it allows us to not to muck around with a bunch of weird exponent and log properties to make it work. Could you do something else? Yeah, you could use any exponent base you wanted to, but like, my life is hard enough. I don't need to make it any harder. Now, Mr. Kulik, you wrote those e's absurdly large. Like, what's the deal with that? Well, student, I do this intentionally to really emphasize the fact that we're not multiplying both sides by e, but we're taking e as the base of an exponential to both sides, right? We're taking e to the left-hand side equals e to the right-hand side. Everybody's okay with that? And the reason we did that is because exponent base e can cancel log base e. And now I'll just write normal sized e's, or normal-ish sized e's. Oops, that was a minus. And then we can just add 1 and divide by 7, right? Does that look okay? We'll swap those x's and y's. And rewrite this as k of x. And I think that will make us dunzos. And you know what? It probably makes more sense if I write this as like 3x divided by 5. A little bit more clear where the x is attached, right? If I start writing a sideways fraction like that, might as well just stick that x into the numerator. Olivia. Of course. No problem.
Wait, where did you put?
It was
Well, 3/5 x is the same as 3x over 5, right? If I'm going to write it as this way and I write the x here, am I talking 3 over 5x? No, I don't want it to look like that. So to reduce any confusion, I wrote it as 3x over 5. So that if you came back and looked at that, it's like, how the heck did the x get in the denominator? That doesn't make any sense. And it's like, it's just, let me write this in a more intelligent fashion. In fact, we'll do that, right? That'll help clean things up maybe a little bit. All right, let's check it, because better safe than sorry. Is it though? Like, who made that thing up?
It's not worth it.
It's not worth the trouble. You're awesome. Yeah, forget it.
Bro, no one's looking at you. Look, there's a window behind you. No one's looking at you.
What are you looking at, Swan?
You're looking at the window.
Oh.
You just stare at the board.
Oh. Why can't I look at the window?
You keep looking directly.
No one cares about you. No one's looking at you. You're not the main character.
Everybody's the main character of their own story. This -1 is this -1. Everybody cool with the composition we did there? What simplifies first?
The 7.
Yeah, Jinx. Does nobody do Jinxes anymore? Is that not cool? It's still cool?
A lot of numbers.
Wow. I guess who we know who's fighting after school. Meet you behind the monkey bars. No knives. All right. Then what?
The 1s.
Yeah. You beat everybody to that one. Okay. Then what?
Oh wait, no, that one. Log E.
Yep. And then just the fraction. Doo-doo.
Move your head.
Can't see it.
Trying to count the blinds.
It's a weird thing to be doing, homie.
It's math class. Why can't I count math?
I mean, okay. Okay.
Whatever floats my boat. I love it.
Are we singing church hymns? I think I heard on Eagle's Wings, didn't I?
It's not really.
We're talking about our favorite song from our middle school.
That's a full story.
It's like we come to dance everybody else's.
Oh, alright.
So you know what I'm talking about?
What?
The top 3 favorite church songs.
That's honestly. Wait, no, what's the one that Father told me was like? Oh, the Kyrie.
All right.
No, he did the Kyrie.
Save the church talk for later. All right. What do we got? Simplifying first.
3 fifths and 5 fifths.
Yes.
And then E, and then plus 1.
They just want to get
That's what I do personally.
And then the E and the log. I think I heard Thomas say that that was next. And then the 1s. And then the 7s. How's that?
That's perfect.
Get the whole thing in there for you. Sorry, I got going kind of fast because people started getting chatty, and I'm just like, oh, they must be boring you. And probably am, but it doesn't mean I need to speed up.
Like, sing it.
I don't know the tune or the name. I just know it's good.
Is it like a Canadian one?
I don't know how you don't do like Amazing Grace, right? Like, isn't that like the oldies?
Only on occasion.
Oh, Carmen. What's the one where it's like some people are dancing with the Lord? Remember that one?
All right. At this point, that's going to close up section 7. So you guys should be able to do up to 56. So I think, what did we... So for Sunday, you guys are going to be looking... For Sunday, Mr. Kulik's going to be looking for 31 to 56. We do have one more section in chapter 1 to do, and then after that we'll be looking at test time. So what do we got? We probably have if I were to take a guess, we got one more class this week. And we have 3 days next. Why are you dodging me? 3 days next week. Probably looking at test end of next week is probably about right. So that's probably about right. We'll talk more once after we finish the 1-8. We'll know.